So I'll be talking about my basic research interest, which is shelf-break exchange processes. And there. So the outline is as follows. I'll briefly mention the regional circulation and hydrography, and then talk about two tools that I've used to understand how rapidly the shelf and slope environment are changing. The Ocean Observatories Initiative Pioneer Array from the National Science Foundation, and then the Shelf Research Fleet, a citizen science project that I never could have imagined 15 years ago getting involved with. The heart of the talk is really about how changes in the Gulf Stream are really having profound impacts on the continental shelf there. I'll briefly talk about bottom intrusions because that was one of the first dramatic processes that we could explain to the fishing community and that they could use to improve their adaptability and sustainability. But I'll really be mostly talking about mid-depth salinity maximum intrusions there. And then finally, near the end, I'd like to mention something that I'm very concerned about, which is some of the recent shifts in the shelf break front into onshore positions well beyond what we've seen in the past. And this has a lot of implications for offshore wind development as well as marine conservation, particularly for the northern right whale. One of the things that Eileen inviting me to talk way back in June led to was I actually gave a talk with the US-Dutch Offshore Wind Consortium about 2 weeks ago in Boston. And we talked about an idea for future cooperation there. So building on what I've learned from the Squid Squad and the Shelf Research Fleet, I'll talk about something that I'm hoping to form in the near future. So in terms of the regional circulation, the Gulf Stream is the western boundary current that's right offshore, that's very well known. It plays a major role in the climate system. Less well known is the shelf break jet that comes down from the Labrador Sea, runs along the edge of the continental shelf, and it's very dynamic. It frequently forms meanders and eddies of shelf water that go out into the continental slope. The Gulf Stream mostly interacts with the continental shelf through shedding large eddies, warm core rings with clockwise or anticyclonic rotation there. And when these get close to the edge of the continental shelf, they drag shelf water offshore in features called streamers here. And the fishing community takes great advantage of these streamers. A retired cetologist, Gordon Waring, told me once his record for sperm whales in a streamer was 58. And it takes a lot of squid, I think, to feed 58 sperm whales. Looking at the hydrographic structure, on the right-hand side are summertime climatologies that Chris Linder did a while ago. And in terms of temperature, the major feature is the cold pool, the winter-cooled water that gets warmed over in the summertime. And these ice attacks here are the geostrophic velocities associated with the shelf break jet. And it's about half a knot in terms of the average velocity, 15 to 20 centimeters a second there. And it's relatively narrow, but it does move cross shelf quite a distance in short periods of time. The typical temperature contrast is 4 to 6 degrees between the cold pool and the upper slope thermostat. In terms of salinity, the salinity gradients tend to be coincident with the temperature gradients. The big change that's gone on over the upper slope, though, and I'll talk about this more later, is that whereas the upper slope used to be 35.0, 35.1, now it's 35.7, 35.8. So there's been a big salting of the upper continental slope, and we'll see some ramifications for that. Okay, this schematic pretty much summarizes my whole career, so I'm always very careful not to delete this file there. And the major point here is that there's a lot of different processes that happen at the Shelfbreak. So I mentioned the Shelfbreak jet. That's a surface trap feature, typically about 50 meters thick there. And ecologically, and I think one of the key reasons why fishing activity is so highly concentrated at the Shelfbreak is that there's a persistent upwelling that results from bottom boundary layer convergence. As you move from a mean flow over the shelf to a weak or even a counterflow over the continental slope, you can get upwelling of between 10 to 20 meters a day, likely on average, and that was measured by Bob Houghton with dye releases in the late 90s there. And that feeds right into the core of the jet. The Shelfbreak circulation is frequently affected by the presence of warm core rings offshore. These have vertical scales of 500 to 1,000 meters, so they can't get onto the continental shelf. But what they can do is drive intrusions at mid-depth, and I'll be talking a lot about these. And we found from the shelf research fleet in particular that bottom intrusions have become more important as well. So the main idea here is simply that the Shelfbreak region has a lot of different processes, and there's a lot of different forcing, wind, convection. There's just a lot going on. Okay, so I mentioned that there are two main tools that I've used to understand the recent changes. And the first one is this Ocean Observatories Initiative Pioneer Array. And there was a big competition from the National Science Foundation way back in 2004, I think it was. And we were very fortunate to have our process-oriented observatory chosen as one of the top selections there. The observatory has been located south of New England. Of course, it's about to move to just north of Cape Hatteras, I believe, in the spring of 2024. And this was carefully situated to minimize both estuarine inputs as well as the proximity of canyons, so that we could really look at Shelfbreak processes in as much isolation as we could there. And there are three main components. A mooring array that's in this yellow rectangle here, autonomous underwater vehicle surveys in this red rectangle, and then gliders in the larger white rectangle. And this is a schematic cartoon of the different components. There's 7 different mooring sites. They have bottom-mounted ADCPs as well as profiler moorings there, which sadly only went up to within 26 meters of the surface. So the observatory was not good for the surface mix layer. And then REMA 600 vehicles were used. Unfortunately, the biggest technological stretch were subsurface docking stations, but there was a managerial decision that the risk of having $1.5 million vehicles out there, if missions had to abort or things like that, it was just too risky. And so the docking station idea was abandoned. And then also gliders were out there since 2015. Generally, the original plan was to have 6 gliders out at one time, but I think they averaged about 3. And data was sent up the lines to 3 separate surface moorings that had satellite communication there. So we had near real-time communications for about 7 years there with the data. This was a godsend to me because one of the most surprising things that came out of the Pioneer Array to me was working closely with the commercial fishing industry. And what happened was in the fall of 2011, there were some public hearings that went very, very badly with the commercial fishing industry. And we ended up having 4 4-hour multi-use conflict negotiations with a staffer from Senator Whitehouse's office as the referee. So she warned us we had to be on good behavior because she was going to report back to every federal legislative office in the Northeast. And the remarkable thing was, after about 6 hours, we actually had a real breakthrough about trust. And Fred Matera, the president of the Commercial Fisheries Research Foundation in Rhode Island, made a number of suggestions for realigning the mooring array so that it would minimize the conflicts, and was just remarkable how after that point, everything really moved forward. And at the end of the 4 sessions, 3 of the fishermen came up to me and Al Pluteman and said, you know, you really convinced us that this array really is in our best interest, because we were going to have a multi-million-dollar lawsuit and prevent it. But you convinced us this could work. So also in that conversation, they said, you know, we've really enjoyed talking to you and learning about the ocean. And 3 months later, we had the opportunity to write a proposal to the MacArthur Foundation for adaptability. And so we proposed to have fishing vessels go out and take CTD profiles, initially at 1-week intervals in 6 different zones across the continental shelf. And that has worked very well. Since late 2014, we've collected over 840 profiles now, and you can see the locations right here of where these have been collected. They give you an idea where the fishing activities are really, really concentrated. That's Cox's Ledge right there. And the thing that's been really remarkable about this effort to me is the amount of knowledge and information that's gone back and forth. So about twice a year, I go and give a talk about the data that's been collected and teach the fishing community about ocean processes and climate change and the effect of El Nino on hurricanes, and learn about squid prices and the crazy tropical fish that they're seeing, and questions about how stratification is changing. It's just been truly remarkable how much information has gone back and forth. And we've really developed, I think, a very nice level of trust. Now, the CTD that we've been using have been RBR concertos. We got great news a few weeks ago. We now actually have federal funds to continue the data collection for 3 more years. And Senator Reid had a press conference last week to announce this to the Rhode Island fishing community there. So I was just absolutely delighted that we had the full support of the 2 Rhode Island senators with that. And then here's a few photos. There's Pete Spong right there, Mark Schweitzer, who's remarkably good with interviews, and then Jim Violet there. Just some photographs there. So the other thing this led into that I never could have imagined was participating in a formal stock assessment. And I was invited to a workshop about short-fin squid. I think it was right before Thanksgiving of 2019. And so I became a part of the group that wrote the scientific working group report for that stock assessment there from last year. And it turns out that we all enjoyed talking to each other so much that after the working group report went in, we all just decided to keep talking. And so during the fishing season there, from about April through October, November, we actually talk every Friday morning at 10 a.m. To discuss the squid catch, how ocean processes are affecting the distribution and the abundance of short-fin squid, and general issues facing the fishing industry in the Northeast. We have about 30 members, and I would say each week maybe between, say, 12 and 18 people show up. We've had 99 meetings to date, and the people from Lund Fisheries actually kept track of every meeting, and they used that as to help get their MSC certification there for sustainable seafood there, which was a big boon to them economically there. I'm also happy to say that Anna Mercer, who's the head of the cooperative branch of the Northeast Fisheries Science Center, has already been asked to form a subgroup for the next stock assessment, which is on longfin squid. And I do have to say that this is the only forum that I regularly discuss cannibalism in, and that's only of squid, of course. But squid actually can't store fat. And so they have to continuously eat. And one of the behavioral adaptations of that in cephalopods in general is actually they resort to cannibalism there. So that led to some interesting discussions for our cruise website there. Okay, so I mentioned that we've been using these profiles to teach the fishing community about different processes. And one of the most remarkable processes that they picked up on right away were near bottom intrusions, warm salty intrusions. And we identified a big intrusion back in January 2017 that I'll talk about next. But this was a really interesting example around Christmas of 2020. I was procrastinating while writing a proposal and was just looking at some Pioneer Array bottom salinities, and I saw that there was a big jump up. And so I thought, oh my goodness, I'm going to have to contact CFRF and let Aubrey Church, who's in charge of the shelf fleet, know that there's a bottom intrusion coming. So I emailed her. 10 minutes later, I got a phone message from Aubrey saying, Glenn, I'm at the dock. I've just been talking to the guys, and they're all asking me if I've talked to you because they think there's a bottom intrusion out there just from their catch and the behavior there. So we talked later that morning, and I thought it was just remarkable. I knew once the intrusion was identified in the Pioneer Array that it would turn off the monkfish fishing. And similarly, because they were seeing that they couldn't catch the monkfish, they were guessing that there was a bottom intrusion going on. So I thought it was really interesting. It really showed how much we've learned from each other. And there's actually a YouTube audio story that Hui put online where Rob Waltz, a fisherman, said, now when I do the profiles, like if I see one of those intrusions, I know that I'm not going to catch any fish for several days. So I'll bring my boat in, I'll have repairs, I won't have to pay the crew. It's really helped me in making my business decisions there. So this is the type of thing I think that's just been wonderful, that the CTD, because it plots right away up on the pilot house on an iPad there, the fisherman can actually use the profiles to decide where to fish there. So going back to that intrusion in 2017, I actually was emailed from Anna Mercer, who was the head of CFRF at the time, photographs of unusual bycatch. So there was a Gulf Stream flounder, which is a warm water fish, that someone caught right off of Block Island, way up, like 7 miles off the coast up here. They'd never been caught in January before. And also juvenile black sea bass, which also, they're common in the summer, but they'd never seen juvenile black sea bass in the winter there. And it turns out that there was a bottom intrusion. This is from a hindcast simulation by Ke Chen, one of my colleagues in Woods Hole. And you can see this big intrusion along the bottom here. He actually was able to compare it to data collected from the shelf research fleet and got a pretty good comparison there. In the paper that Ke wrote that appeared in 2021, there were two conditions that were necessary to get a strong onshore intrusion: winds from the west that would give an offshore Ekman transport near the surface and a return flow near the bottom, and also a cyclonic eddy near the Shelfbreak that tended to sharpen the frontal gradients. And then this is just a transect right here over several days showing the development of these bottom intrusions there. Kahn, that paper, had a detailed analysis of the momentum balance and everything there. But it's just an example of how the data collected by the fishing community we've put to very good use in terms of basic research and understanding the dynamics of these processes. Okay, so now I'd like to talk about my main topic, which are these mid-depth salinity intrusions there. And these have been known all the way back to the time of Bigelow, way back in the 1930s there. And there was a really, really nice paper by Steve Lentz in 2003, a real classic paper on a climatology of these intrusions. And he defined several characteristics of them. And this is a figure from his paper. So this is depth right here, and this is the salinity. And so this is a salinity maximum intrusion right here. S max is this maximum value right here. In this case, it's nearly 35. Z sub m is the depth at which S max occurs, which in this case is about 35 meters. Delta S is the difference between S max and the ambient salinity there. And then delta is the thickness here as well. And then also just the water depth there, and distance to the Shelfbreak. So key results out of this, the S max occurred in 10% of the profiles sampled before 1998. The frequency decreases away from Cape Hatteras, and it's the least frequent off Georges Bank in southern New England. The salinity maximum occurs at the depth of peak stratification. Some intrusions did get far onshore in Steve's data, but the vast majority stayed within 30 kilometers of the Shelfbreak. So in the early days of the COVID pandemic, I had some time to actually go through the Shelf Research Fleet data and start hunting these intrusions down to try and update Steve's climatology. We had recently been funded for some field work to try and map one of these intrusions. And so I wanted to put that pandemic time to good use there. And that was that, of course, that golden, wonderful period before the world discovered Zoom. And I really had time to look at the data. So there's some differences when I looked at the Shelf Fleet data from what Steve did. For one thing, there was a lot of asymmetry above and below the intrusions. And that was because there was a lot of low salinity water up near the surface. Of course, in Steve's profile, it was well mixed right up to the surface above the intrusion. You know, but we've seen a lot of salinity stratification near the surface there. But the most important difference is that Steve used a delta S of 0.1 PSU. And I would have had so many intrusions particularly in some of the deeper profiles. I actually had to kick that contrast up to 0.2 in order to have a manageable, countable number of intrusions there. So as I was going through the Shelf Fleet data, this is all from 2015 to 2019. I think it was 621 profiles I looked through. So about 120 per year there, 10 per month. This plot here shows all the profiles with no intrusion in black, and in green are the profiles with intrusions. And one of the things that jumps out is we've got lots of profiles with intrusions way up here, 100 kilometers north of the Shelfbreak here. And so these intrusions are penetrating much further on shore. This is a histogram of the S-max value. The average was 33.6, and the peak in the histogram here was between 33 and 33.5. And Delta S was mostly in the range of 0.2 to 0.4, but there were still values well over 1.5 here, and you can see this distribution right here. The big surprise to me was how much the frequency of these intrusions had occurred compared to the lens climatology. Now, this is a little bit of apples and oranges here because, of course, Steve took profiles from Georges Bank down to Cape Hatteras. I was only looking at southern New England. But this is the average frequency here as a percentage of profiles averaged over the 5 years for the red line, 2015 to 2019, and from Steve's climatology. And overall, there was a 68% increase in the frequency over the whole year. I was amazed that it was that much of an increase there. There were 109 out of 621 profiles. That's 17.5% here. And you can see that in August and September, nearly half of the profiles had these intrusions. So they're really, really increased there. Another thing that I think has a lot of ecological consequences is that we had a number of profiles with multiple intrusions in it with delta S greater than 0.2. This was our most amazing example out of the 5 years. Here's a profile with 4 intrusions in it right here. Now, this may be very ecologically significant because I have seen in acoustic backscatter data where we're getting the water column with multiple profiles, we're also getting the zooplankton in the different layers as well. So this may act as a mechanism to actually decrease the maximum concentration of zooplankton there, which certainly has implications for the feeding of northern right whales there. About 10% of the shelf fleet profiles from 2015 to 2019 had 2 or more intrusions. But as we'll see in the Ecomon data, it's a much higher percentage. So I started collaborating with Paula Frattantoni, who's head of the Oceans and Climate branch of the Northeast Fisheries Science Center. And she said, hey, those are interesting results, but isn't a fairer comparison to actually use the Ecomon data? And so that goes all the way back to the 1970s. But she only used data from 1990 on because all the data was from CTDs there. And this is for one particular year. The red stations are ones that are sampled every time. The blue ones are random stratified stations. And so they shift around within the different boxes there. She used 21,486 profiles in nearly 30 years of analysis there. So well beyond the number of profiles that I handle. And she got a very similar result in terms of the increase of the frequency. August is a little bit funny. It's not quite as high as the shelf fleet number, but you can see that both July and September, the numbers are almost spot on. The overall annual number was less than 1% different. I think she had 18% and I had 17.5% there. So this was very gratifying to see that a spatially comparable comparison was for Steve's climatology actually gave the same result as with the shelf fleet. Now with the shelf fleet, again, because we've collected data over 60 different months there, we can actually look year to year, month to month to see that frequency. And while there's huge variations year to year, we can see the 2019 had in September had the largest frequency, 75%. 2015, it was very high, over 50% for the entire summer there. And one obvious question is, are these related to warm core rings? So what is happening with the Gulf Stream? I first heard about increased Gulf Stream variability indirectly at a workshop with 4 members of the fishing community in January 2013. Fred Matera, who was the one who reconfigured the mooring array with his helpful suggestions, pointed out that the number one thing that they had observed in the Rhode Island fishing community was that there was a lot more Gulf Stream water on the continental shelf. And so I filed this away in the back of my mind. A couple years later, I was working with my colleague Magdalena Andres with our PhD student Jacob Forsyth. And Magdalena was going through the envelopes of the northern wall of the Gulf Stream positions, the 25 centimeter sea surface height anomaly contour. And what she found was that in the mid 1990s, the large amplitude meanders really only formed very far east. This red dot indicates where it hits a certain threshold for the variance, but that this example in 2014 is typical of the period after 2000 there, where the meanders were both larger amplitude as well as forming further to the west, so that the north wall could even come in close proximity to the Shelfbreak. And Tal and Larry Atkinson had a very nice paper about that several years ago. In addition to becoming wigglier, as Magdalena calls it, my colleague Avijit Gangopillai has been working with the Jennifer Clark Gulf Stream charts with several students. I've been on all these students' thesis committees, and they found that there was a big regime shift in the year 2000, where before 2000, from 1980 to 1999, the average was 18 rings per year, and then it jumped up to 33 there in the year 2000. We're still trying to understand dynamically why this big shift occurred. It wasn't the wind stress curl. Vijay just had a master's student finish up, and we're writing the manuscript now. But this brought a lot more rings in close proximity to the continental shelf. Avijit's student Adrian Silver, for the last chapter of her PhD thesis, looked carefully at the relationship between warm core rings and these salinity maximum intrusions using the ECOMON data. Again, we collaborated with Paula Fratantoni, who's just been fantastic there to work with. And there's really 3 stages with the rings here. The initial pinch off, translation along the continental slope through what Adrian calls the ring corridor. And then when they get to close proximity to the continental shelf, SMAX intrusions actually tend to be located near the rings. And in fact, she found that 72% of intrusions from ECOMON over a 30-year period were within 50 kilometers of a warm core ring there. Perhaps even more remarkable was that when she did the Rodionov regime shift analysis there, that looks at sequential variance there, at the same time that the rings nearly doubled, the frequency of the SMAX intrusions quadrupled from 6% to 24% there. So these intrusions tended not to occur nearly as frequently before the year 2000. And this plot on the right shows in the red here the SMAX frequency, and this is from 1990 to 1999 compared to 2000 to 2019. You can see how much darker it is here. This is at getting up to 50% of the profiles along the Shelfbreak, particularly south of New England and along George's Bank, was very low, less than 10% before 1999. So there's a real, well, we absolutely need to explore the dynamics. We need more modeling studies. There's a strong link between the warm core rings and the presence of the SMAX intrusions. So I mentioned that we were funded to do a field program. We called it CIRITS, to rhyme with pirates. And it stands for Salinity Intrusions, Rings, Autonomous Underwater Vehicles, Turbulent Squid. The cruise I'll be describing was on the Neil Armstrong from June 18 to July 2nd, 2021. We had a number in the science party. Vijay did go. It was very nice seeing him at sea. His student Adrian, my student Lucas Lobert, Amy Kukulia, and the robotics group that operated the long-range AUVs I'll describe in a second. And Ruth Musgrave, Svenja Ryan, Anna Mercer, Paula Fratantoni, and Susan Inglis from the Commercial Fisheries Research Foundation were all our shoreside support team. Susan actually was tweeting about our cruise, was sending profiles and everything all during the cruise. So we were hearing back from the fishing community while we were at sea, which was really great. And Adrian designed the logo with a very aggressive squid here. Okay, so I had some nearly sleepless nights before the cruise thinking, how are we going to find these subsurface intrusions? And luckily, the ocean really gave us a pretty easy answer to that. This is the SST image here from the Rutgers Cool Room the day before we went out. And you can see that there's two eddies here. It turns out they were counter-rotating. This is a big warm core ring here. And this incredible thermal front right here, mostly running along the 200-meter isobath, but you can see these two large wave crests right here. So we decided to go down the 71 degrees west line close to this wave right here. The Pioneer Array was just maybe 4 or 5 kilometers to the east of us. And this is just the overall sampling during the cruise right here. Red circles are shipboard CTD, and blue are AUV lines right here. This box is the long-range autonomous underwater vehicle there. And we were able to identify right from the first transect 5 different profiles with SMAX intrusions in them. I was just overjoyed on the ship. And so we were able to use the sea surface temperature patterns to identify the subsurface feature. As you can see, each of these 5 profiles has a very different vertical structure. The first one here has 3 SMAX. This one has 2. This one has just a very thin one right here. So this gives you some idea of the incredible 3-dimensional structure of these. Now, we used the Tethys class long-range AUV that was invented out at the Monterey Bay Aquarium Research Institute. And this has an endurance for the sensor suite that we used of about 2 weeks there. It goes down to up to 300 meters there. It does have a buoyancy engine to give it more endurance there. And we used it to make a box when we first got out there that was about 40 kilometers by, I think it was 13 kilometers. And you can see this is a visualization by Svenja Ryan. We really caught this salinity maximum intrusion right here. The maximum value of the salinity was 35 over the continental shelf here. This extended 33 kilometers shoreward of the Shelfbreak front, which is the offshore boundary of this greenish cold pool water right here. And this is the foot of the front right here. You can also see it was very warm, over 20 degrees centigrade here, even though this was mid-June. We also had a vertical microstructure profiler that Erica Green, a student of Sam Kelly's at the Large Lake Observatory up in University of Minnesota, Duluth, sampled. And this is just an example here on a short transect showing the structure of the nose of the intrusion right here. Here's the temperature. And we also were able to get measurements of the turbulent kinetic energy dissipation and the turbulent diffusivity there. I won't talk about that now, but we were really able to see the mixing on the underside of the intrusion. A big goal of this was to actually determine the along shelf scales, and we caught this very nicely in this Remus 100 section with the AUV. We can see the path it followed here. We were operating between the surface and 50 meters depth. This was 14 kilometers wide right here. The delta S was 1.5 PSU, which is 3 times that mean value of 0.46. And it turns out that amazing front of the ring water there really resulted from counter-rotating eddies over the slope. ADCP measurements from a 38 kilohertz instrument show that there was a 40 centimeter a second cross slope flow that was 400 meters thick. So there was an incredible transport towards the Shelfbreak that was bringing this warm, salty water to the edge of the shelf that could then provide the gradients necessary to push the intrusion on shore. Now, one thing I just want to mention here, we don't know the dynamics of this yet. We have to do more modeling. There's clearly a connection to the warm core rings. But I think one of the key reasons the intrusions are occurring more frequently, in addition to more warm core rings, is that we're getting marine heat waves much more frequently in the Northeast. This is a figure from Grosser-Lindemann et al. 2022. This is the number of marine heat wave days per year here in the Northeast. Since 2010, there's been a big jump up for marine heat wave days. This is the spatial pattern of the warming rates from NOAA OYSST. And it's interesting that it's both the core of the Gulf Stream coming off Cape Hatteras and along the continental slope where we might expect the warm core rings to go that have the highest warming rates here. In terms of the increasing stratification, this is from the Pioneer Array inshore mooring. We're getting enormous differences from year to year in terms of the minimum surface density in the summer, nearly 2 sigma theta there from year to year. And so finally, June 2021 was just a really remarkable month. And when we got back and Adrian Silver looked at the sea surface temperature imagery and the Jennifer Clark charts, there were 8 warm core rings that Jennifer Clark identified on June 8th. So this was like a week before we went out. This was the ring that we were basically in close proximity to, that we actually took the ship out into. But you can see there's another even larger ring further to the east, and these smaller rings, these are probably 2 aneurysms right here. So we were supposed to have our second cruise in September 2021. And one of the crew members on the Endeavor got COVID the week before the cruise. So we were kind of bummed out. Okay, we're going to get postponed for another year. But Amy Kukulia, the head of the Cybotics group, said, I've got the long-range AUV all gassed up here. It's all charged. Can I just take out the rigid hull inflatable boat? I'll just launch it off a Cutty Hunk and we'll send it south. I said, well, we'll need a little bit of money from NSF. They were gracious and gave us a little bit of money to do this extra mission. And I could not believe it in September of 2021. This is the path for this transect right here. So she launched the LRAV right here, right off Cutty Hunk Island, head south and then southwest, and then go due south along 71 degrees west. This is the salinity from the long-range AUV right here. Yellow is 34, which I consider to be the inshore edge of the Shelfbreak front. This is inside the 50-meter isobath. So the shelf break front, which should be down here, was all the way up at mid-shelf. I was truly astounded. I just had never seen it that far inshore before. But because we had the Pioneer array out there, we could actually look at the salinity. This is the 7-meter near surface instrument frame salinity time series. This should be a flat line of 33, this whole time period right here. But you can see that it's gotten up over 34 for with substantial week-to-week variability over this 5-month time period right here. And it was up as high as 35 for some of the time periods here. I was amazed that it could stay onshore for that long. Typical meander periods are 4 days. I've seen rings push things around for 2 or 3 weeks, but this was for 5 months. Looking at the NDBC surface temperature from buoy 44008 at Nantucket Shoals with Ka-Chen, this is the time series here. The 2000 to 2010 mean is this blue line with 1 standard deviation. 2012, where there was an enormous marine heat wave, is in the light blue, and 2021 is in red here. In September, mid-September, when LRAV went out, there was a greater than 6 degrees C warm anomaly out there, entirely consistent with the shelf break front moving way inshore there. And it was really higher than 2 degrees centigrade for several months here leading up to that really large anomaly. So this has big implications, I think, for both offshore wind as well as marine conservation here. So basically, the shelf break front that we normally expect to see here moved into this position for about 5 months. We don't know if the upwelling was stronger or weaker when it moved to this inshore position. It would be really, I think, logical to conclude that the volume of shelf water that was coming down was greatly reduced, since the outer half of the continental shelf was actually occupied by slope or ring water there. Now, this led to a really unusual summer. Bluefin tuna that normally are in the canyons for most of the summer and then run on shore late August, September, they were located near Block Island from mid-June on. Charter captains were only having to go 20 miles offshore instead of 80 miles offshore to catch bluefin tuna. People caught a lot of bluefin tuna the summer of 2021. The outer half of the continental shelf had lots and lots of yellowfin tuna there. And in addition, we were getting emails, even while we were out on the cruise in mid-June, that the largest aggregation of marine mammals that the Rhode Island fishing community had ever seen was at the 50-meter isobath, where this upwelling cell would be. I still want to follow up with some cetologists about that, but we were just hearing all sorts of anecdotes. And apparently there were traffic jams with pleasure boats because everybody wanted to go out and see the humpback whales that were close to Block Island there. So that's pretty much the science part. And one interesting development. In discussions with the Squid Squad, Sarah Geiches said during one of the calls back in January of this past year, you know, it's really tough because we manage the ecosystem on a single species basis. You know, we're hearing so much from the Squid Squad about how the oceanography is all tying in. We're hearing about how different species are relating to each other. And so I got the idea that I tried to push for our WHOI strategic plan for a Center for Integrative Marine Ecology. In a similar concept to the Squid Squad, where we could get people from very different backgrounds to talk about large-scale features that are affecting shellfish, tuna, squid there. And I was thinking that it would be very informal with minimal management and bureaucracy and combined scientists and stakeholders, including possibly people from the offshore wind industry. The thing I've learned about working with the commercial fishing industry is trust is the most important factor of all. I think it's also interesting to get academics to learn about the incredibly rapid timescales that industry, particularly the fishing industry, has to operate under there. I've learned a lot about staying on top of things. And then finally, these informal groups are really crucial for building trust and establishing personal relationships necessary for really dealing with multi-use conflicts. I'm very proud that the fishing community wanted the Pioneer Array to stay south of New England. I think that's a pretty remarkable evolution from wanting to have a multi-million-dollar lawsuit to wanting it to stay in the area over 10 years. So the conclusions are ocean observatories and cooperative research are important for understanding the very rapidly changing oceanographic conditions in the northeastern US. A significant increase in Gulf Stream variability has resulted in substantially more intrusions. I forgot to say earlier in the talk, I'm very much impressed by Jamie Poulter's work with Afonso Neto, her student, about how the Labrador Sea slope water was cut off in 2010, and that led to downstream warming. I think we have to put the warm core ring story together with Jamie's work there. And then also the seasonal movements and timing of different organisms are being strongly affected by all these hydrographic changes. So I'll stop there and take questions.